Welcome to the Resairchia YouTube channel. My name is Jorge, and in this video we will continue with numerical analysis with F#. We will be using AngouriMath like in the previous video. Here you can see their website and the documentation. But I also recommend visiting their GitHub. Here you can take a look to the different sections and become aware of the different possibilities, restrictions, or issues. And also give them a star if you like their work. Again, as in other videos, you will find the links in the description. In this video, we will do some review of calculus while I show you some of the different options available in AngouriMath to perform the fundamentals needed in calculus before taking more advanced topics that we will be using in numerical analysis. First of all, F# makes a difference of numbers with or without a decimal part, so we need to be careful when working with integers or reals. Now imagine we have a function, for instance 1 divided by x. What happens at 0? Well, if we approach 0 from the right, we get positive infinity. However, if we approach from the left, we get, I wrote the wrong value. So yeah, if we approach from the left, we obtain minus infinity. So we have a discontinuity, in this case, an infinite jump. So to have a continuous function, there are no jumps in the function, no big changes in values. Or as it is called, there are no discontinuities. We will plot this example using Scott plots. First, we load the library or package scott-plot. Then we open it to be able to use it. And then I create an array of values from -10 to +10. And then I replace those values in the function. And then I simply create the plot properties. And we save the plot, which in our case looks like this. As you can see, at 0, there is one value right before it and another value right after it. This continuous line should not be here, but I kept it just to show my point. So as you can see, there is a big change from one value to another. Now I will load AngouriMath to continue with the calculus review. Again, we load the library. You will need an internet connection, and then we open the different parts of the library that we will be using. To review calculus, we need to start with the definition of limit. A limit is the value that a function is approaching to as the input of that limit is approaching some value. I will go back to the previous example to show what I mean. First, we define our limit as 1 divided by x when x tends to plus infinity. This means that the bigger and bigger that our value of x becomes, the closer and closer we are getting to 0. We can try a different number, for instance 5, and reevaluate numerically. Now that we have introduced limits, we can continue with derivatives. Among other requirements, by definition, for a function to be differentiable at a point, the following limit exists. This limit would be the definition of derivative. When a function of x plus an increment that tends to 0 minus that function of x divided by the small increment. But I just realized that writing it like this, it's confusing. So let me write it again. In this case, our function would be very simple, just x or x plus the small increment plus 8. So when we evaluate, as we all know, the derivative of x with respect to x becomes just 1. When solving limits, sometimes it is useful to simplify the function beforehand. So as you can see, when we simplify everything, we get 1 directly, which is exactly the result of the derivative. We can compare by using a derivative now. Directly using AngouriMath, the derivative of x with respect to x becomes just 1. Now another function a little bit more difficult. So our function would be x to the power of 2. So when we write it in the limit, we write x plus a small increment to the power of 2 minus x to the power of 2 divided by the small increment when the increment tends to 0. And then we obtain, by using the limit, exactly the derivative that you should know. It's x to the power of 2. The derivative becomes 2 times x. We can use the derivative function from AngouriMath directly to derive x to the power of 2 with respect to x and directly obtain the same result, 2 times x. Now we will try something a bit more challenging. We will try the limit of the sine function. This one is a bit more challenging to compute. So we are getting not a number, although it should be the cosine. Computing limits is a difficult task for computers. It is not so obvious to do on a computer program. So what if we help a little before computing the limit? We can take the power series expansion of sine and then compare it afterwards with the cosine power series. I will take only 2 terms just to keep it simple and make it easy to follow. For these power expansions, I will leave a link in the description so you can read about them if you are interested. To reduce it. You can see also how to write the factorial. So this is the expression that we get. Now let's use it with the limit. We wait a moment and then, as you can see, we get the power series expansion of the cosine. Now we got the actual result from the limit properly. This is, as one would expect, the derivative of the sine, we obtain the cosine. Now I will take the example of an indetermination, 0 divided by 0. Sine of x divided by x, when we do the limit of x that tends to 0, we would get an indeterminate value. However, using AngouriMath, we are actually getting the correct result, 1. How do we get here? Well, there are two options for computing this limit. We can use the series like before, and you can see that when we evaluate the limit, we actually get 1. The other option is using L'Hopital's rule. I will leave a link in the description for how to use L'Hopital's rule. It's actually a very powerful tool, but it's not always the solution for solving limits. Using L'Hopital's rule, we derive the numerator and the denominator separately. Be careful because, as I said, it's not always the best option. We derive with respect to x, the sine of x, and we derive with respect to x, x. So what we will get is cosine of x divided by 1. And now we can write the limit again. As you can see, cosine of x divided by 1 when x tends to 0. We evaluate and solve the solution. Exactly as expected, 1. To complete this first part of the calculus review, I will show you how to perform an integral. I will continue using the example of the sine, and we get the minus cosine. Talking about integrals will need another video, since I need to talk about different kinds of integrals, Riemann sums, and so on. If you already knew enough calculus, I hope this video helped you out to become familiar with AngouriMath. Otherwise, I hope you learned some new things about calculus, or you could remember them now and learn how to use AngouriMath and the different options available. Thank you so much for watching, and see you in future videos.